All right, so let's look at our first one of these problems, and they are quite a lot of calculations. So the average of grade point averages, GPAs, of college courses in a specific major is a measure of difficulty of the major. An educator wishes to conduct a study to find out whether the difficulty levels of different majors are the same. For such a study, a random sample of major grade point averages of 11 graduating seniors at a large university is selected for each of the four majors: mathematics, English, education, and biology. The data are given in the table. We want to test at the 5% level of significance whether the data contains sufficient evidence to conclude that there are differences among the average major GPAs of these four majors. Okay, so let's begin our hypothesis test. First thing we're going to do is our null hypothesis is always going to be that the means are the same. So we've got four different areas here: math, English, education, and biology. And we're just going to say that mu1 is equal to mu2 is equal to mu3, and we got four of them. So all four of those are the same. And we'll just assume this one's mu1, this one's mu2, this one's mu3, and this one's mu4. All right. And then our alternate is always that not all of the population means are equal. So that's that one of these may not match the others, or several of them might not be the same as the others. Okay, so first thing we need, let's note that alpha was 0.05 from above. All right, and we're going to come up with our value for our critical F value. All right, now to get the critical F value, we're going to use the F chart, but before we can use it, we need to come up with two things. We need to know degrees of freedom 1, DF1, and that's always going to be K minus 1. Now, K is the number of categories we have. We have four of them. So this is 4 minus 1. The first degrees of freedom is 3. And then degrees of freedom 2 is N minus K. N is the total amount of data we have. And if we count up all of this data, there's 44 pieces of data, and there were four categories. So DF2 is 40. Now to find our critical value for F, we're going to use our chart. And I think I have it pulled up over here in the background. Let's see. Yeah. All right. So let me move this over because this is a little bit difficult to see. All right, now, first thing we need to do is find DF2 on the left side. So we want a DF2 of 40. Oop. If I can get my scroll bar to work for me here. All right, so here's 40, but these are large tail numbers on the left, and we want 0.05. So let me see, I may be too high on the chart. Yeah, here we go. All right, so here we are with a DF2 of 40, and here's the 0.05 that our alpha is. Now, let me scroll up just a little bit so you can see this. At the top is our DF1. All right, so we have DF2 of 40 with 0.05 as our alpha. Let's go over to the column where our DF1 is 3. And we see that our critical value is 2.84. All right, so let me put that back on here. Our critical value is 2.84. Now, this is always going to be a right-tailed test, just like our chi-squareds were. So if we get, for our test statistic, anything to the right or bigger than 2.84, we're going to reject the null. But here's where it gets ugly because our computations that we need are going to be difficult. In fact, let's just go back to our notes for a second. Here's all this computation that we have to do. First thing we need to do is find the mean for each of our four categories, and then we're going to use that to find the overall mean for all of our observations. Okay, so to do that, we're going to cheat and make it easy on ourselves. We're going to use Excel. So I'm going to take this table and I'm going to copy it, and I'm going to paste it into Excel. All right, so now that I've pasted this into Microsoft Excel, I'm going to go down beneath each column, and I'm going to get the mean for that column, and I'm going to get the standard deviation. Now, in Excel, we're going to hit equal average, and since I'm finding the mean for all 11 pieces of data in column A, I'm going to tell it go from A1, which is our first cell, to A11, our second cell, and there's the mean. All right, now, later on, we're going to need the variance for this column as well. So we're just going to hit equal variance.s, that's our sample variance, and again, we're just going to tell it A1 all the way to A11. And it calculates the variance for us. And we're going to do this for every single column. So I'll do the same thing here, equal average B1 to B11, and equal variance.s, var.s, for B1 to B11. Now, for the sake of time, I'm going to do this. All right, so I've gone ahead and done these, and we have all of the means for each of the columns and all of the standard deviations. Or actually all of the variances, not standard deviations. All right, now we need to go back and we need to first compute the overall mean. And to do that, let me go back here. X bar, oops, X bar is going to be, all right, so what we're going to do is we're going to compute a fraction. We're going to take the number that were in column A, there were 11 pieces of data in column A, times the mean that we got for column A. And then we want to add that to 11 times the data in column B, and its mean was this. And then 11 pieces of data in column C, and its mean was this. And then 11 pieces of data in column D, and its mean was this. And all of that is divided by the total number of data, which was 44. And if we let our calculator do that, that ugly information gives us 3.153181. All right, so that's X bar. Now, let's notice though, after we've gotten our X bar, let me go back to our formulas here so you can see what we've got to do. We have to find this MST and this MSE because our F is actually these two values divided by each other, MST on top and MSE on the bottom. So we want to take, let's notice, the amount of data in the first column times the mean of that data minus the overall mean squared. And we're going to do that for each set of data. And then on the bottom, k minus 1. All right, so using that formula, that's our MST, we had 11 pieces of data in column 1. Its mean was this amount, and we want to subtract off this value we got right up here, 3.153181, and we are going to square this. And for the sake of time, I'm just going to write it like that. All right, and then let's do the same thing for our second one. We had 11 pieces of data. The mean was 3.335455 minus the mean that we got overall is our answer in that last little computation. Then we square it. And then we need 11. And our third mean was 3.359091 minus the mean that we got overall in the last computation. And then we want to square that. And then I'm going to run off the page here, so let me kind of move this over. Our last piece of data will have 11, our last column I should say, and its mean was 3.015455 minus 3.153181. All right, now truly all of this computation from here to here is the top of the fraction, so that's divided by k minus 1, or we can think of our degrees of freedom, number 1. So it's divided by 3. All right? And if we do that huge and horrible computation, we end up getting 0.576834. All right, now that's our MST. Now we have to find our MSE. And we go back and look at our formula. This is actually a little bit easier than the first one, although not easy. We're going to take the amount of data we have in each one of our categories and subtract 1, and then multiply it times the variance, and add each of those up. And then we'll divide by n minus k, our degrees of freedom 2. All right, so let's do that. So, in other words, if we go back and look at our what we got on our Excel sheet, we're going to have 11 minus 1, so there's really 10 pieces of data, times the variance, which for our very first one was 0.188062. And then we want to take 11 minus 1 again, so 10, and the second variance, which was this. And then we want to take 11 minus 1 again, so 10 again. And our third variance. And we want to take 11 minus 1, or 10 again, times our fourth variance. And all of that gets divided by our second degrees of freedom, so the 40. And if we do that, we get this calculation, or this value. All right, now we are finally ready to find our test value f. F is the MST divided by the MSE. So it's MST divided by MSE, which is, in this case, 0.576834 divided by 0.180306. And if we put that into our calculator, we get 3.199. Now, let's recall from above, our critical value was 2.84. 3.199 is certainly to the right of 2.84. Remember, it's always a right-tailed test. So it is in the rejection region. We reject the null hypothesis. So there is enough evidence at alpha equal 0.05 to reject the null. And let me pull this down a little bit. And since we're going to reject the null, that means the alternate is going to be true. Not all of the population means are equal. Some of these majors are more difficult than others. Now, we can't conclude which ones are. Further studies would have to be done to see which ones are more difficult. Now, we can kind of look at it and guess which ones are, but without further studies, we can't actually conclude that with our evidence yet. All right, now, I just want to state this while we're looking at this problem. This is a lot of computation. So on a test, you can kind of expect that I may give you X bar, I may give you MST and MSE. So all you've got to do is find that critical value up top and then know how to find F, and of course to make the right decision in rejecting the null hypothesis or failing to reject the null hypothesis.